Welcome to this short film by the TOPNES collaboration. We are a group of scientists working at universities around the world who are trying to understand the behaviour of new types of materials. Our world is governed by materials, and solid materials have a wide variety of properties. Metals conduct electricity easily, while insulators don't. Semiconductors are in between and are crucial for modern technologies. Some, like iron, are naturally magnetic, but others are not at all. So, what makes this variety possible? The different behaviour of electrons in solids. Theoretical physicists explain matter using simple models, since a lump of material that you can hold in your hand contains around 10 to the 23 atoms. There is no way that we can understand states of matter by following each particle. By states of matter, we don't just mean solids, liquids, and gases, but also properties like magnetism or superconductivity. Fortunately, for many states of matter, we can think about thermal equilibrium. This occurs when things are left alone to relax. Something sitting alone in a room will reach equilibrium. The great thing about thermal equilibrium is that anything that can happen does happen, with a probability that depends only on how much energy it requires. We don't need to follow the motion of all particles. Unfortunately, not all matter is in equilibrium, only the things that we can easily understand. We are trying to find what states of matter exist out of equilibrium when there is energy flowing. Energy flow can make many things happen. When you heat a saucepan of water, energy flow sets up complicated convection patterns. Energy flow can massively change how a system behaves. A famous example is Kapitza's pendulum. Shaking the support, the pendulum switches from behaving as you expect to instead flip upside down. We study this kind of behaviour at the quantum level, producing new states of matter. While it might seem impossible to shake individual atoms, shining light on a material does exactly this. Light of the right frequency shakes the atoms just like shaking the support in the Kapitza pendulum. When you do this, all sorts of new states of matter can be created. We hope to use this to find ways to switch the properties of a material. The aim of our research is to study the atoms and electrons in materials to understand why they have the properties they do, so that one day we can make a material with any property we would like to have. Imagine making a material which you can write on and tastes as good as chocolate. There would be much less waste paper. If we've got you interested and you'd like to know more, here's what to do. Do you already know a bit about physics? Then check out these videos, which have been made with you in mind. Looking for a simpler introduction to what we do? Then have a look at these. For details of our research and public engagement activities, here's a link to the TOPNES website. Thanks for watching.